Hi everyone. In this video, I'm going to show you how to compile your lab notebook, which you will be submitting weekly. You can find the files that I'm mentioning right now in the labs folder on Canvas. I'm going to give you a template so that you have some framework for how to do your lab notebook. And then I'm also going to provide you with one really good example of a student who just nailed it and got all of the details that you need to highlight or accentuate on your lab notebook. Every week you will do a submission for this. Whenever you do the submission weekly, you're really just going to be providing me with a subset of information and not the entire notebook components, but this way it just kind of helps keep you accountable for the information every week, and it helps make it so that it's not a nightmare for us to grade at the end of the quarter if we're being realistic. So I'm going to share my screen with you guys, and we will show you what the components of this lab notebook are. So first, this is going to be the template that you can find on Canvas. It is a Word document, but you are welcome to use Google Docs if that works for you. Every week, I will give you the common and scientific names for the plants that are being propagated, and then you will also get the date propagated and the method used. The method used, you want to make sure that you are including any sort of treatment that we're doing for this. So if we're doing leaf cuttings and we're doing a hormone versus control, you would tell me that it was a leaf cutting and it was a hormone versus control. The next component that you're going to need is an image for the plant. Make sure that when you're pulling up the plant image that you're searching for the entire scientific name, and then also if we specify a cultivar, that you're looking for that cultivar, because you will come to find out that the internet doesn't always know what it's talking about when it comes to plants, and common names are used multiple times for different species. So we really want to have that picture be as accurate as possible. The next set of information that you're going to need are the growing pieces of information. So your light requirements, mature height, and water needs. And these are going to be things that you will have to look up on the internet. There are some sources that are more reliable than others. Really great sources include the Missouri Botanical Gardens, or um, there's a lot of stuff that'll come up that has really accurate information for growing information. For light requirements, typical answers are full sun, part sun, or shade. For the heights, I really want you to put this in metric. So I know that you'll get a lot of pings from the internet that are going to be in American Standard Units, but that's not really the language of science. So we can do better than that, and we can convert any of those heights to metric. So if you don't put metric here for the mature height, you will lose points on this. So just save yourself the grief and just convert everything to metric. If you don't know what the conversion is, just Google it. If you just type in what is 24 inches in metric, and it'll just come up magically. You don't even have to know the calculations, okay? And then water needs. So water needs are going to be another thing that you'll find. Typical answers for this are going to be uh, moderate water, low water, drought tolerant. Xeric is one that you'll see sometimes. Xeric refers to something that doesn't require any water at all, typically like a desert species. Or frequent water. Those are the kinds of language that you'll see for your water needs. Next, you'll include some weekly observations. You won't necessarily have observations for every plant every week, but I will provide those in the PowerPoint slides that you guys get. So each of those will have a date associated with the observation, and a lot of times it'll just be a picture. So you'll have to look at the picture and determine some sort of feature from that picture. Are the leaves starting to yellow? Does it look like the leaves are dropping? Does it look like there's rot that's happening from the base? Um, I will try not to give you too much busy work, as in saying like there won't be anything that you get that should be no change. Everything that I give you will have some sort of change in its features for you to observe. So you'll just put the date for the observation. It won't be the date that you're looking at. Some of these videos were shot last year, were filmed last year. Some of these I started propagating like 6 months ago to prepare for this class. And so there's going to be a little bit of a cooking show component to this that I kind of mentioned in the other video. So uh, make sure that you're putting the appropriate date for those observations so that we can really make sure that's dialed in. Next is going to be your results section. Your results section is going to be the final raw data. So if you had a certain number of things root in one category and not in another, that's where you would put this. And then you will also get p-values associated with that. So we're going to run a statistical analysis on any of these that were actual experiments. So anytime we were doing a comparison, and then we will provide you with those p-values towards the end of the quarter um, when we're doing day to day. And so you will give us a statement here that says there was no significant difference between the treatment and control, or there was a significant difference between the treatment and control. And then in parentheses, you'll give us that p-value for those statements. And I'll talk a little bit more about how to do that when we get towards day to day so that you really get that dialed in. Partial points are awarded for the statement, partial points are awarded for the p-value and making sure that it was an accurate statement, that your statement reflected what actually happened. And then lastly, you guys will provide us with a concluding statement. The concluding statement is either going to be what you found most interesting about the experiment or how we could improve this experiment in the future. You will see that some of our experiments don't necessarily work out the way that we wanted them to. Sometimes it's a soil media issue, sometimes it's a pest issue. Regardless, you'll find things to nitpick about here. One that's going to just kind of show that you're being observant and you're critically thinking about these experiments, and two, that'll help us kind of shift our focus or figure out how we want to modify those experiments for the future. So now I'm going to stop sharing this and I'm going to switch to an example of a really, really good lab notebook that someone turned in last year. Okay. So here is that example. They've given us the common name, which is jade plant, the scientific name, Crosdale argentea. I've already put this box as a text box in there, so you should be able to just copy and paste your picture from the internet right there, and you don't necessarily need to cite that source. It'll be fine because we're not making any money off of this, so we don't have to give royalties to anybody or anything. We'll have the date that you propagated it. That's going to be the first date. In some cases, it might have a 2020 there. It might be a propagation from last year. If the experiment worked really great and we don't have anything to change about it, you will get a video that was from last year. However, there will be some things that we update this year as well. Here's the method used. So they've specified leaf petiole cuttings and IBA versus no IBA. That's one way to say this, or you could say IBA versus control. That would be the second way to say this. Then we got our growing information. The light requirements for this particular plant were part shade. The mature height here was 60 to 90 centimeters and up to 3 meters in a natural environment. So sometimes you'll see a difference between whether it's cultivated or wild. Sometimes you won't see that difference. And here the water needs are drought tolerant. Here's an example of those weekly observations where you can see here they're showing some browning, or they're saying a difference between the two. And each week they're just providing us with a little bit more information and that associated date. Then we've got some final data numbers here within that, nested within that. Here's an example of the results. So in this experiment, the hypothesis that rooting differed between control and IBA was found to be false, with the p-value being less than 0.05. But the hypothesis that rooting differed between species, we actually did 3 different kinds of things for this one. It was aloe, jade, and snake plant. So that was found to be true. Okay, these numbers are not going to be the same for us this year because we are doing this experiment again. So we may even have another component in there where we factor in year to go along with this experiment. And then last, we have this concluding statement where they're mentioning that they found that the IBA treatment didn't really significantly affect rooting, but it did differ between species. And so this person suggested that we could control our environmental conditions, such as the amount of water or light given, and that might make this experiment more robust. If you have questions on how to compile this, please reach out to me. You're welcome to come to office hours whenever we have those scheduled. This will be due weekly, and your weekly component that you're going to be responsible for is this chunk up here. So we'll tell you which plants you learned and how many entries you need to have for this, and then you will give us back this as a submission every Saturday night. So you'll have the list and you'll need to Google the information, and then that's what you will submit to us each week for a point value. Okay. All right. That's all I have on this topic for now, but definitely feel free to reach out if you have any questions, comments, or concerns.